Okay, so we're going to do these miscellaneous questions from 2024, 2023, 2022. These are just the weirder questions um, from these papers, and we're just going to go through them one by one because you don't really need any background knowledge on them. Not a lot. They're kind of disconnected from the rest of the course, so we can have a look at them one by one. So let's have a look at this first one. You can see it's from June 2023, so quite recent, just a couple of exams ago. The triangle shows the triangle shown in Figure 4. Question 4a, Q4a, is a copy of the four triangles joined as shown in the figure. That's really bad English, as these guys usually can do really well. Like four triangles shown as shown in the figure B, arranged to enclose a square of ABCD. Show that the area of ABCD is equal to x squared plus y squared. So they're asking us to find the area of that like square in the middle of it, right? And they've given us a triangle around the outside edge, and it's a really, really easy problem. It's a very quick problem. So let's have a look at it. But we've got to get our head around what they've been trying to say. Well, I think we just did. As they're asking for the area of a square, right? And we know the area of a square because we've done that lots of times before. That's just going to be the base times by the height. So it's tilted on its side. But let's just grab one of these guys as well. Let's grab one of those triangles. And this is x, and let's call this guy x. Let's give him as x, sorry. Given as x, and this is y, and let's call this guy like z or something. So if we call this one z, then the outside of our square would also be z. So the area of this square will be z squared, right? So if we can work out what z is, then we can square it and we get the answer. So let's see if we can work out what z is based upon the rest of this triangle. Let's see. We're going to have x, because of Pythagoras, we can say a squared plus b squared is equal to c squared. Well, this can be equal to a, and this can be equal to b. So this is going to be x squared plus y squared is equal to, I suppose, z squared. And that is actually what we're trying to show. But that's a bit strange. So I wouldn't normally do this. I would then square root this to then get a z by itself. Okay, so we want the area of a square. So now we can say that the area of the square, so let's say it's actually a square, is going to be z squared. So that's going to be this whole thing squared, and the squared and the square root cancel out. And that's what we're trying to show in the problem. We've actually shown the area of the square is x squared plus y squared, which is all they wanted to see. That's it.